Good morning, everyone. Good morning. Welcome back. Hope everyone is doing all right. Hope everyone is enjoying August. It's calm, it's been peaceful and quiet, and I trust it's been the same for you. Um, so good to be back. Appreciate I didn't post a video last week. I was out. I had a few things to sort out. I had one important thing to sort out. That's behind me, and going to focus on delivering content here on until the next time I have something important to sort out. At the end of the last video, I hinted that I didn't quite have a subject for the video today, and I tend to simply find these subjects as I move along. I make it up as I go along almost. But I had a bit of an idea a few days ago, and I wrote this up a few days ago. The subject I've known about for a while, and I trust a lot of you know about this as well. The subject of today was established near 2,500 years ago on the island of Samos in the Dodecanese Islands. He is a man that we all know and love and paved the way for mathematics, trigonometry, geometry everywhere. I'm, of course, talking about the great Pythagoras himself, hailing from the year 570 BC, I believe, to 495, 500 BC, something like that. Um, he was the one. He was the man who paved the way to what we now know as Pythagoras' theorem. I was doing a bit of reading earlier, and it seems the theorem itself has been known long before. The Babylonians knew about the formula when they were constructing the Hanging Gardens. Even other civilizations had inklings, or even they were aware of such numbers that we could square together to make another square. So Pythagoras himself, he was the one that sort of formalized it and popularized it. Who knows? Maybe he simply had a better publicist than the Babylonians. Not a great deal is known about Pythagoras himself. Not much is written about him today. Not much was written during his life, and whatever was written about him during his time or written by himself was most likely destroyed or lost 60 years later in the Peloponnese Wars. So right now, people like myself are left with resources, Wikipedia, etc., or going down to the local library to learn more about him. But that's not going to deter us today. We have Pythagoras' theorem, which before it was known as Pythagoras' theorem. I believe it was Euclid himself who was the first one to coin the term Pythagoras' theorem. Before then, we simply knew it as, or they simply knew it as, for a right-angled triangle, the sum of the square of the two sides adjacent to the right angle is equal to the sum of the hypotenuse. So that's all well and good, and we use it to solve angles or solve sides for triangles. The Egyptians used it, the Babylonians used it, many other civilizations used it. That's all well and good. So the subject of today, we're going to focus on Pythagorean triplets. So whole number solutions to Pythagoras' theorem, of which there are, I assume, an infinite number. There are at least many. There are many that we know of. The classic 3, 4, 5 that we know, or 6, 8, 10, which is simply a multiple of 3, 4, 5. 5, 12, 13, 9, 12, 15, 8, 15, 17. I can go on. But the point is, I don't have to go on. We don't have to go on, because we're going to produce a script here that'll show us exactly what they are. So that's all well and good, and that'll be what we're going to be up to today. So let's do that. So we're on C# online. In fact, no, we're not, because today we've got C# on Visual Studio. I finally installed it. I finally figured out how to do it, and I knew this was going to be a bit of a battle. It took me about 2 hours to get this sorted out. I downloaded it off I can't remember where. It was a bit of a long process. I wrote some of it down. I can write a whole video of this process itself of trying to install Visual Studio, sorry, and I think that was one of the problems I encountered. There was Visual Studio and Visual Studio Basic, and the guidance was if you're an experienced pro, then you'd use Visual Basic, and if you were a novice, I believe, or if you were, I can't remember, a novice or starting out, you'd want Visual Basic. So me being me, I thought, well, let's simply go straight to the top. Let's go for Visual Studio. And I was hopelessly caught out and didn't know how to work Visual Studio, and I realized, yes, before it must have been Visual Studio Basic. So now here we are on Visual Studio Basic. I'm not going to make that mistake again. It looks nice. I like the colors. It's definitely standout different to programmers. So I thank programmers for its service and getting me used to and equipped to C#. So now here we are on Visual Studio and we're gonna get on with it. So today is August 25th, 2025. It's Monday. And I'm gonna get on with this quickly because I have a few things to sort out later on. Oh no, it's not because it's a bank holiday in the United Kingdom. So I guess I can take a bit of time more to do this. So um, yeah, no, let's get on with this and let's clear the board and let's make this script. And it's going to work exactly the same as Programmers, so I don't believe there should be any problems. So I'm going to create this new class. I'm going to call it Pythagorean Triplets. Let's get on and create that class. So I'm hoping this could be a fairly short one today. I wrote this not long ago and it's still fresh in my head. So I'm going to create this main string arguments, and that's interesting. I don't. Is that any feature? It's telling me what I want to. When you saw it just came up, it was suggesting me the string args, and what I want the string args for. It's because I might want to change around a few of the variables later. It means I can define the variables up front or the parameters up front. And I don't have to keep changing them around in the script. And what are those two arguments? It's going to be a lower bound, which I'm going to set to simply 1, and the upper bound, an integer upper bound at, I don't know, let's call it 100. So how exactly is this script going to work? So if I go down to the bottom, the statement of Pythagoras' theorem is, oops, someone caps up, no, not a squared plus b squared is equal to c squared. And what I'm aiming for, what I hope to do here is, I wish to run this for all the values of c. So starting with c equals 1, c equals 2, c equals 3, etc., all the way up until c 100. And I'm going to fix c basically for the while being, while a and b cycle through the digits of 1 and 100. So for c equals 1, it's going to run a equals 1, b equals 1. Any solutions found? No. Skipping ahead, c equals 5, let's say. C equals 5. Is there any solutions for a equals 1 while b equals 1, b equals 2, b equals 3, etc.? No, there's not. C equals 3 again. A equals, moving on, a equals 3. B equals 1, b equals 2, b equals 3, b equals 4. And there will be a solution. So we're basically looping inside for each a, b, and c. Okay, so what does that mean, or what does that even look like? Let's continue. So if I set the stage for c equals the lower bound, and see again, it's telling me what I want to do. This is very cool. I've completely forgot about this. So and it's telling me what I should do, and I have no qualms with what it's saying because it's already identifying the bounds, what I want to do with this, and it's telling me as well the C++. Maybe it's C#, C++, telling me that I want to run it as long as there is something to run it over, so the 1 to 100. So I'm not sure how fun this is. This is no, it is fun. Yeah, I'm not going to take it away. Thank you, C#. Okay, so what do I want? So I want a bool found equals false, and let me find that. The bool found false. I want to find something, but I haven't found it yet. It's linked to the printing of the triplets once I found it. So once I found it, we trigger it to true and we can deliver a message. Otherwise, if there is no triplets found, then I can simply give the false trigger and it'll produce another message for that. Maybe that's not the best way to explain it, but I realized I couldn't do this without the bool function. I was trying without the bool earlier. I thought I could write the simple loop, but that didn't happen. Okay, so what do I want? I want to run this. Let's say for, so that's what I said earlier. It's going to start for the integer c. It's going to start from c at the lower bound, and it's going to continue up until the upper bound. But the first inside loop, it's going to run this for all a starting from 1. But as long as a is strictly less than c, so emphasis on this word strictly less than, otherwise, we're going to end up with a lot of trivial solutions. So we're going to simply end up with A0, B equals 0, C equals 0, which it's no fun. I don't want that. I don't much care about that. So we can simply skip that out. And so while A is cycling through, we can do the same with B. So we can, I just gave the game away there. We can start it from B equals 1, but then we'll simply be duplicating solutions and we'll get A345 a equals 4, 3, 5, and we don't want that. So instead we can move on, start b from a, so we don't have to duplicate our efforts. B, C, oops, less than C, and it's again, it's telling me what I want to do. It's telling me what I should be doing. I don't. Thank you very much. And what else do I want? So that's it. So those are the 3 loops. But we need the condition now for what is this actually solving? So I want another loop there. So if, and this is the actual statement of Pythagoras' theorem. So A cross A plus, it's doing it, it's telling me, B, remember, so equals C squared. So remember, we're using the double equals because it's an if, it's a function. So we're using the equals in conjunction with the if. We're not simply saying that a squared plus b squared strictly equals c squared. Okay, so what happens now? So now we want a message in the console, and see it's not going to give me a suggestion because it doesn't know what I want to write. So okay, so what I want it to say. So if I have a Pythagorean, how do you spell this word? Pythagorean triplet. Pythagorean triplet found, then I want you to simply output that. What are they? So it'll be A, whatever that A is that you find, whatever that B is that you find. Yeah, and C as well. There we go. It's telling me. It's telling me I want C. Okay, good. So C equals C, whatever that C may be, and I can close that. Okay, and that is the logic, the true logic from the Boolean function we applied earlier. So again, I don't know why we need this. I was trying to figure out why we couldn't simply do it without. Couldn't do it, so I'm simply going to let it be. So what about if we have no solution? So if none found, so again, we're linking up to that found here. I just noticed something. I'm going to come back to that. I think you all saw it too. Console, right line again. What I want to tell me if there are no solutions found. Very simply, no Pythagorean triplets found. That's how you spell it. Pythagorean triplets found for whatever the instance of C equaling whatever that C is. Okay, and I think that's good. What was that? 32 lines. I think that's good. So I'm gonna run it now. Let's see what we get. Great, look at that. We have our triplets. I think we're in triplets. Good. So no triplets found. So there we go. There's the classic 3, 4, 5. The 6, 8, 10, which is simply a multiple of 3, 4, 5. 5, 12, 13, etc. We can go on with this. There they are. They're all down there. That is fantastic. So poor Pythagoras, he had to do this by hand or paper or sand and stone, I suppose. He would have to wait 2,000 years, 2,500 years for C sharp. What did I say earlier? C, MATLAB, etc. So here we are, man. This is fantastic. I can extend this, I believe. I can go to, what about if I simply did 10,000? This will keep going. Look at that. Interesting to note, this is the PowerShell or the command prompt, the external window that it's running into, or running the program into. So remember before in C# programmers, there was the added side window. So it was split between the script and the console. So here we actually have to go to an external console. And that's what you're seeing here. This is the PowerShell or the command prompt. Okay, so that's going to cycle through. I get the point. I think you get the point as well. Great. So I'm pretty pleased with that. Hope you found that interesting. I'm going to scale this up by 1 power of the index. So I'm sure Pythagoras had triplets nailed down. What about the next one? What about quadruplets? So quadruplets, we're going to extend this idea further. So what is the quadruplets? It's going to be a cubed plus b cubed plus c cubed is equal to some d cubed. So it was all well and good earlier when we can associate this with a square or a triangle. So the two sides of the triangle adjacent to the right angle was a and b. But now we're trying to scale this up to 3D. So what would A, B, C be in this case? So they're cubes, aren't they? But what are the cubes? Um, where are the cubes coming from? What are they? I don't know. It's a problem now involving 4 dimensions, 3 dimensions. Anyway, we'll get on with that. The statement of it is at least that much clear. We need to solve for that. Okay, so good. I'm going to continue on here, and I'm going to write over this. So let's call that simply the cubic quadruplets. No spaces. I have to remember that. Cubic quadruplets. And I can still use the same static void. I can still use the same upper lower bound. But for now, I need to add in these new parameters. So D is the final there. So I'm going to have to change that. D there. And I'm hoping this is there is a simple addition somewhere. False. For in A equals 1, I'm going to have to run this for less than D, as long as A, no, that's correct, yeah. A plus plus. B is equal to A. B here will be less than D, yes. And that will keep going for B, yes. What is it, E? We need another one here, yeah. Okay, so for A equals B plus plus 4, I think I'm going to add to, yeah, okay, so now we need the C. And I'm going to have to find some way to shift this all across in a minute. So int b equals, no, was it C equals b. Yeah, there we go, it's telling me. C, sorry about that. C equals b, and then what? C less than d for C sharp, C plus plus, sorry. Okay, so then what? I need to move that in a loop. I can't have that yet. So if, yeah, I need that, and I need that in a loop. Yeah, so I'm gonna have to. Okay, so if, and this will be the statement here that I need. Okay, A, B, I need another B, B cubed, and I need to shift C over to this side. C, and that will be D, D, D. Okay, okay, and so that'll be that. So if A equals that, I get it. So that'll be my console there. I can shift that across, and shift that across. At least give it the illusion that I have found true. So I need to update this. So Pythagorean quadruplet found. So A equals A equals A, C, and then D is equal to D. Yes. So we're simply amending this around this new formula, or the new expression that we want to find. I think I can move them all across perfectly well, no problems. I think I'll need to lock in that there. No, it's not letting me see because the found, it will. I need to do that. Shift, shift, shift. Shift U, shift U. Maybe I was best off writing this all from scratch in the start. So C, if found, console right line, no quadruplets found. I say no quadruplets found. For D is equal to D. Okay. So is that it? I hope that's it. Found. So we simply changed that equation there. That's all we need to do. And we've added in the additional, we've moved C over to the other side and shifted it all to revolve around D. So can we run this now? Not for 10,000, but 100 at least. So let's run that. Run. Okay. There were build errors. Okay. Here we go. That's a problem. Last. No. Okay. Fix this. What did we do here? Cubic quadruplets. Is it going to tell me what the issue is here? Invalid expression term. The name C does not exist in the current context. Yeah. Okay. I understand that. C. What is C here? It's telling me it doesn't like C. But why not? C equals D. C plus plus. Yeah. I know. What's wrong with C? Oh, did I have to establish it earlier? I think I did. Yeah. Yeah. Nice. D. B is less than D. B plus. For C is equal to B. C less than D. C plus plus. So then I'm inside the loop. A is equal to A. Yeah, that's it, because I shouldn't have closed that. That shouldn't be there. Yeah. Yeah, okay. Gotta be careful there. Okay, now what? Great, okay. There we go. Okay, we've got some quadruplets now. Look at that. Okay, 3, 4, 5, 6. Yeah, 1, 6, 8, 9. I believe those are. I believe that's correct. Yeah. I'll get out my Texas Instruments BA2 plus and just verify for cube there. Yeah, 27. 4 to the power of 3. Yeah, is that at 64? 5 to the power of 3. Nope, not 53. Oops. Sorry. Come here. Yeah, 125. And what does that equal? That is 216, which is, it should be 6 cubed. Okay, good. So these look good. Oh, these look good. Okay. So that's fine. That's all well and good. So we've got quadruplets. And now let's finish this. Let's do one last thing. Let's see if we can do one last thing. Um, so let's see if we could do this moving forward one last time to quintuplets. No, what is it? It'll be quartic quintuplets. Quartic quintuplets. Okay. What do I mean by that? So I wonder if Pythagoras ever made it this far. A4 plus B4 plus C4 plus D4 is equal to some E4. Now, this goes well beyond the realms of 2D and 3D. I'm not even sure what sort of shapes we're solving for here, but the point is we're solving it for something. Right, so let's quickly do this, and that'll be the quintics, quadruplets. Have I got this correct? Yeah. Okay. So E, I'm hoping I can simply make a simple amendments to this. So that would be E. That would be E there. And ball found false. A is equal to 1. A is less than the E there. E. Okay. E and trying it again. B is equal to A. B less than E. Yeah. B plus, yep, and C is equal to B. C is going to be less than E there, C plus plus. And I need to add in D somewhere. So that will be here. So for integer, D equals to C. We don't want to repeat that work. That's why we're doing that. C less than E, and as long as D, we have something to run this over for D. So I need to add a line here, and I'm going to get into a bit of trouble because I don't quite need that yet. So that's where that if is. So I'm going to do something a bit different here. I'm going to scrap that. So to save us going all the way up, I'm going to use the math power function, which is simply a to the power of 4 and everything else. So again, I'm going to do that math power power b4 as well plus math dot power c4. Oopsie. Okay, math dot power d4 is equal to math power e to the power of 4. Okay. Okay, otherwise this would get a bit hefty, trying to write all that out again. So I'll still need that console right line Pythagorean quintuplets found, and I'm going to do the exact same thing here. I need to add them all in. E is equal to whatever that E is. Okay, and found true, yeah. Push that over there. Now I need to be careful with what my brackets are here, because there's a loop that's not closed, and I think I'll, yeah, break that there. I think that's the break I need. True. How many more of these are? So that should be 1, 2, yeah, you're looped, you're closed there. Okay, so the console right now, no Pythagorean quintuplets found. So quintuplets found for E is equal to E. We don't want the D, we want the E. Good. Okay, so I think that's fine. I'm going to run that again. Are we fine? Yeah. No. Okay, look. So look, it's when I'm using index power of 5, no, index power of 4, when I'm solving for quintuplets, so I want 5 now. Yeah, we've got a bit of a problem here. So these are massive calculations that we're working out. These are big sums. 1 to the 5 is fine. Even 2 to the 5 gets a bit hefty. 2 to the 5, 64? 32, sorry. And as soon as we start hitting what 5 to the power of 4, sorry, 5 to the power of 4 with 625, 10 to the power of 4 is no, 10 to the power of 4 is 10,000. We're already dealing with some insane numbers here. So I'm gonna end this here. I don't know, are there even any solutions to this? I believe there are. There is a solution. I don't want this video to run on too long, but I'll save this for another video. I'll continue this, and again, the Pythagoras theorem can be extended on. There's the Pythagorean triplets, the quadruplets, the quintuplets. Um, I'll sort of leave that to run on the side there. You can see the script that we ran here. This is kind of what we care about here, and we can do other such things. So there are two things I want to do. There's first of all, I guess I'm not entirely happy with the way this is being run. These are a lot of loops. You don't want to keep running for a equals 1, do the same for b, then c. There must be a way to sort of optimize this, streamline the efficiency of it, so it's not. I get the feeling calculations are being done sort of more than once over these loops. So that's one thing. But bear in mind, I get the feeling we're going to lose sort of robustness here because C sharp is sort of cutting off the decimals or cutting off some of the digits here. So there must be a way to let it handle large numbers. So I need to figure that out next. But that'll be story for another day. For now, I'll leave this here. But I hope you found this interesting. Again, if it's a subject that a lot of you would have touched upon, you might all have heard about in some shape or form. Um, so yeah, I hope you found this interesting and I hope it's useful. Let me know in the comments what you think. Let me know what your thought. If there's anything I could change, if anything I can do differently, always happy to hear it. Always happy hearing suggestions, thoughts, and criticisms as well. So let me know. And for the rest of you in the United Kingdom, enjoy the bank holiday. Enjoy the day off and do something. Hope you do something. Get up to something nice. So yeah, we'll see you next week and we'll continue on with this. Thank you very much, everyone. We'll see you again soon.